So in today's class and video, we are going to look at an artificial substrate known as p-nitrophenol phosphate and another compound p-nitrophenol. So this is the molecular structure for p-nitrophenol phosphate, and this is for p-nitrophenol. We'll start by looking at p-nitrophenol phosphate. So p-nitrophenol phosphate is a non-proteinaceous chromogenic substrate used to measure the activity of enzymes. Example, the activity of alkaline phosphatase and acid phosphatase. It's a chromogenic substrate because it produces a colored product when it reacts with the enzyme, and its other name is p or para-nitrophenol phosphate or 4-nitrophenol dihydrogen phosphate. Its chemical formula is this: C6H6NO6P, and its molecular structure is this. It is used in a variety of assays, including ELISA assay and the spectrophotometric assays. The next is p-nitrophenol. So first of all, what I want us to note is that p-nitrophenol is a colorless to pale yellow crystals. So this is how it looks like. So p-nitrophenol is a phenolic compound with a nitro group. So this is the nitro group over here, and this is the structure, the molecular structure for p-nitrophenol. So with a nitro group on the opposite side of the benzene rings of the hydroxyl group, and its other name is 4-nitrophenol or 4-hydroxy nitrobenzene. So now let us look at its reaction in acidic medium and in alkaline medium. So we'll start by looking at the acidic medium. So in acidic medium, p-nitrophenol is colorless and dominate below a pH of 5 in this medium. And also in this acidic medium, it is in its non-ionized form. So normally p-nitrophenol in the acidic medium is colorless over here, and it can only absorb light in a UV range. Again, in a basic medium, it is yellow. So this is the basic medium. It is yellow and dominate above the pH of 9.5. And also in this medium, the p-nitrophenol exists in its ionizable form as p-nitrophenolate, which gives a yellow color and has a maximum absorption at 405 nanometer. So this is just chemical reaction illustration how the alkaline phosphatase or acidic or acid phosphatase hydrolyzes the artificial substrate p-nitrophenol phosphate into p-nitrophenol, so which is colorless in this acidic medium, and also upon the addition of sodium hydroxide to increase the pH or change the medium to basic, the p-nitrophenol over here is being ionized to p-nitrophenolate and turns yellow and absorbs light at a wavelength of 405 nanometer. Reaction of p-nitrophenol phosphate. So you start by looking at its reaction with alkaline phosphatase. So when p-nitrophenol phosphate is present with an alkaline phosphatase, the alkaline phosphatase hydrolyzes the pNPP in the alkaline medium to a yellow color of p-nitrophenol and inorganic phosphate. So again, this is the reaction showing the enzymatic cleavage of the alkaline phosphatase on the artificial substrate p-nitrophenol phosphate to produce a yellow color p-nitrophenol and an inorganic phosphate. So reaction of the p-nitrophenol phosphate with acid phosphatase. Now, so when p-nitrophenol phosphate is present with an acid phosphatase, so the acid phosphatase hydrolyzes the p-nitrophenol phosphate into p-nitrophenol, so which is colorless in the acidic medium and inorganic phosphate. Now, so increasing the pH medium by the addition of sodium hydroxide, one will stop the activity of the acid phosphatase, and to convert the colorless p-nitrophenol produced to a colored p-nitrophenolate ion, which absorbs maximum light at 405 nanometer. So this is also just a chemical reaction explaining the reaction of the artificial substrate p-nitrophenol phosphate with acid phosphatase.